I'll admit everyone.
Good evening.
Good evening, everyone. Good evening, everyone. Thank you very much for joining. Welcome to ICorr Aberdeen branch event for October. And today we have got event on NII special event thanks to our presenter Neil and Susan. My name is Mohammed Ijaz and I'm ICorr Aberdeen branch chair. And we have got quite active ICorr Aberdeen branch here. And we usually have a quite good turnover over the year, and we have got quite few technical sessions planned for this year and the next. So few procedural remarks. Please keep all your mics muted, please, because it would be difficult to hear more than 2 people talking at the same time. We would request you to switch off your cameras as well, just to save the bandwidth as well. And the CPD would be issued after a survey. You will receive a survey hopefully in 2 to 3 days, and you would, if you complete that and request a CPD certificate to be issued, you will have a CPD certificate issued within 2 weeks' time. We would be having a presentation today by Susan. So the format is that we would have a brief introduction by ICorr, then the presentation by Dr. Susan, and after that we would invite Dr. Neil to present his part of the presentation. And once we finish with that, then we will have a question and answer session hosted by our Vice Chair, Human. And after that, I'll introduce you to our next presentation next month, and then we can actually from there finish the afternoon. A bit of introduction to our ICorr Aberdeen branch. As already welcomed you, and we've got our 5th decade as a branch. We have been going very strong over the years, and this year we have got about 11 events in the session. We will be seeing you again in next session in November. So if I can move my slides, I can probably do better, hopefully.
Sorry, just a note, Ijaz, for the question and answer, we have the chat box. If you may please ask your question in the chat box, so we will be able to ask the question at the end of the session. And this event is recorded, just for your information. You can have access to that later on the ICorr website.
Yeah. So we have successfully adapted to the new COVID-19 situation with very well attended ICorr webinars and full event program. And we are continuing to expand our technical program. And thanks to our all of our institute sponsors as well as our branch sponsors, please feel free If you don't have your company logo in there, please feel free. You can contact any of the Aberdeen branch members, and we would be very happy to guide you through the process. And it's not that much amount of money actually for the branch sponsor. It's only about £300 for the sponsorship. And thanks to all of the sponsors we have on the board. The next bit is just showing the strength of Aberdeen branch, and that's our 2021 committee. The new member is Lianling Bei from BP joining us this year. We have got all our previous presentations stored in Google site. We are converting all that information into ICorr.org official website, which is the Aberdeen branch site. And that's our committee for this year. Quite famous and quite few known people in the industry here. We have got a good quite few years of experience, I would say, if not decades of experience in corrosion and integrity. As Human has mentioned already, that we would be recording this session for our good attendees and not join us today from all over the world. So we would be recording this for everybody. So let me introduce our first speaker for today. That's Dr. Susan Osbeck, who's principal consultant at ESR Technology. She has been active in supporting clients with non-intrusive inspection in oil and gas industry since 2011. She was co-author of the updated HOIS Recommended Practice for NII HOIS R103 and HOIS Guidance Notes for NII HOIS G103. Susan has experience in a variety of fields, including bioengineering, radiation protection, radiography, integrity management, data analysis, and surface science. She holds a degree in physics and medical physics and PhD in engineering from Robert Gordon University, where she investigated improving interfacial bonding between carbon fibers and epoxy resins for the aerospace industry. With that, I would like to invite Dr. Susan to take over the screen, and please put your hand together for Dr. Susan.
Okay. Well, yeah, thank you very much for coming tonight. So I'm going to be talking about updates that have been made to the recommended practice for non-intrusive inspection. So I'll start off with an introduction just to set the scene, and then introduce non-intrusive inspection. I'm going to give some history to the recommended practice and summarise the NII process. I'll highlight changes that have been made to the recommended practice, and I will also introduce the new guidance notes. Finally, I will finish with giving an example of where the recommended practice has been applied, and I'm also going to talk about future projects that would be of interest if you're interested in non-intrusive inspection. So to start with, integrity management decisions rely on a lot of information from different sources. Obviously, you get a lot of, you make your decisions based on your corrosion risk assessment, and you've got a lot of monitoring available to you, for example, corrosion coupons or corrosion inhibitor monitoring. But really, inspection is the only thing that provides you with a solid confirmation of your corrosion risk assessment. So inspection is really important for making good integrity management decisions. Traditionally, for pressure vessels, this has been done by internal visual inspection, so actually putting somebody inside the pressure vessel. And the problem with that is that the vessel needs to be shut down, isolated, and cleaned to be able to have somebody in there for prolonged periods of time. So obviously that's a very costly and hazardous activity, and it's obviously a very understandable desire to remove that activity. And that's where non-intrusive inspection comes in. So NII is a process, it's not a technique. It uses non-destructive testing techniques within it, but it's a whole process. So it's usually carried out externally of the pressure vessel, and normally when that pressure vessel is online. So you don't have to shut down and you don't lose any, you don't suffer from having to have production losses. Sometimes it may be carried out while the pressure vessel is offline, if it's particularly a hot vessel or something, but normally you can do it online. The thing is that internal visual inspection is usually much more flexible than NII. When you put somebody into a pressure vessel, they are able to look around it and not necessarily have advanced knowledge of what type of degradation they are looking for, and they can change their inspection techniques. They can add in extra inspection techniques while they're in there if they have concerns. So in order to do NII, we have to think a bit differently. And there's a really big emphasis on understanding the degradation types that could be in a pressure vessel, because inspection techniques are very morphology specific. So they have different probabilities of detection depending on the type of degradation that's there. One technique may be very good at detecting wide pits, but if it's a very narrow pit, that technique may fail to pick it up. So it's really important that we have an understanding of it. And because of that difference to IVI, the industry recognised that there was a need for a framework to improve the confidence in NII. So just to give a brief history of the recommended practice, NII has been being used well before 2000. It was being used in high value cases, and there was a lot of design for the inspection coming from the nuclear industry. It started off in 2000 that there was a move to have this more rigorous approach to it. So HOIS started development of NII guidelines, and that was driven by operator members and the UK HSE. And at the same time, ICorr Babcock sponsored a project into NII, and those outputs were shared and included within the HOIS development. Some pilot projects were run with ESR technology in ConocoPhillips and Marathon, and then there was some wider application by a limited number of operators. So following all that sort of testing, 2007, HOIS published the first set of recommended practice through DNV, and it was published as DNV RPG 103. So the choice to publish through DNV at the time was because HOIS didn't enjoy the public awareness that it has now, and it was to try and reach as wide of audience as possible with the publication. So following the publication, there was a wider industry uptake. And we saw extensive application between 2007 and 2010. And by the increased application, obviously, people realized that the recommended practice could do with some updates. So in 2011, the year I started in NII, the second revision of the recommended practice was published, and it included options for deferring instead of just replacing an internal visual, and also had requirements for the evaluation phase of NII. Again, there's more increase in 2011 to 2017. We started seeing more uptake around the world. HOIS also developed a recommended practice on statistical analysis of inspection data to help support the evaluation phase of NII. And operators started building in NII into their internal processes and started setting targets for the use of NII. But again, we realized that there was, with the greater interest in NII, there was time for another update. The OGTC also supported greater industry uptake of NII. And there was more interest in having NII thought about from the design stage of building vessels. So in 2017, another project was started to update the recommended practice. And finally, this year in February, we managed to get the third revision published. And this time it was published through HOIS as HOIS RP 103. So I'm going to talk about the updates to it today. At the same time, we also published guidance notes to support the recommended practice, and that was with the support of OGTC, and that was published as HOIS G103. So the NII process fits very much into the whole Energy Institute's idea of plan, do, check, and act. I'll go into each of the processes a bit more in detail, but the plan is where you assess whether NII is suitable and develop a work scope. The do, inspection, the check, evaluation, and the act, updating your RBI. So the NII process, we start with an assessment where we review the process of the vessel, the process history, the inspection history, the corrosion risks. And like I said before, this is a really important phase, and it's really important that we get good corrosion knowledge or input into this phase. It's at that point you determine the suitability of the vessel and determine what coverage is required, what techniques, and the locations. You then develop a work scope to provide instructions to your inspection team and include your reporting requirements. We've also got the inspection phase. Sorry, I just realized I didn't have the plan, do, act, check, act there. So in the do part, the inspection phase, you inspect the work scope and any additional inspection if required. So although I said IVI is flexible, NII is less, if you're out there and the technicians find some corrosion, they may extend the work scope depending on what they find. So the report is generated from the inspection showing what locations were covered, if any anomalies found, and what the minimums were. And then the final phase, the check phase, is the evaluation, where you review how well that inspection matched the actual work scope. You analyse the results, trend data, calculate corrosion rates if required, and confirm or update your RBI and act on any recommendations from the evaluation. So I'll start going into some of the updates. So the first phase, like I said, is an assessment, is screening, where you're determining a very high level whether a vessel would be suitable for NII. And there used to be this question, was the vessel designed specifically for NII? And what we've done is we've removed that question, because even if a vessel was designed specifically for NII, doesn't necessarily mean it would be still suitable for inspection. So that's now been removed. But in the screening phase, we now have first in-service inspection. Previously, if the vessel had never been inspected before, and it wasn't similar to vessels that you already had history for, it was advised that you should do an internal visual inspection. But particularly in Australia, where their first inspection is due within the first year, an NII approach is still preferred. So we've now got a section where we've got FISI, or first in service inspection, where you have to have, again, a much stronger corrosion risk assessment than you would for, say, another NII, and you have to do a lot more coverage and things. Once you've gone through the screening, you go into the actual suitability. So there's this flow chart, which basically asks 3 questions. It looks at the confidence and ability to predict the type and location of degradation, the previous inspection effectiveness, and the severity and rate of degradation. So obviously, if you haven't got a lot of confidence in what in the corrosion that's there, you really probably should think more about doing IVI. And similarly, if you have a very severe rate of degradation, it's got much higher consequences, or there's more likelihood of there being higher consequences if you were to miss some degradation. And this flowchart just takes you through it. The new guidance note provides suggestions for the selection, so they try and help out with some examples about how to determine each of these levels, how to determine the answers for these questions. if you determine that a vessel is suitable for NII, there are 3 different strategies you can take. There's type A, where the aim is to confirm that there's no onset of degradation, which would be a sampling inspection. A type B, which is to confirm your predictions, which would also be a sampling inspection, but at a higher coverage. And a type C, where you're confirming absence of flaws of a particular defined limiting size, and that's like 100% coverage. So changes that are in the recommended practice now, the flowchart on the right there is new, just to help people who are perhaps more visual in the way they read things. And type A. So type A was originally intended for vessels that are corrosion-resistant alloys, or clad internally with a corrosion-resistant alloy. So the idea was it's very much to confirm there's no onset of degradation. But we've now allowed, we've explicitly allowed carbon steel vessels, but the proviso there is that they really do have to have a very good history of no corrosion at all. And it is very unlikely you would see corrosion. So it is more along the lines of dry gas processing vessels. The recommended practice also now has much more more detailed descriptions of how to set the requirements for an inspection. So there's now calculations to help you calculate what sort of coverage you should be applying in the case of type A and type B inspections. There's also tables to help you set the probability of detection requirements. So that's the depth of imperfection or a depth of flaw that you're looking to basically find, and what aspect ratio that should be at, so as in how wide it is compared to its depth. It also gives tables for accuracy as well, which are based, and both this probability and detection and accuracy are based on consequence of failure or some other value. So like I was saying earlier, the strategy and the inspection requirements rely on a good understanding of the likely degradation. And one of the new things in the recommended practice is this idea of density and homogeneity, and it being related to spatial distribution. So in the see if I can. So on this drawing, for example, you've got 2 boxes. You've got a red box around an area, which is got a lot of degradation in one small area. So you would call that quite a high density. Whereas in the green box, it's a low density. There's less flaws within the same size of area. But between the two, they're very different in terms of the spatial distribution, the homogeneity. If you imagine, because if you look at the big image, you think that, well, this is quite homogeneous. I can't do it. It is pretty much the same everywhere. If you were to take a sample, you should be able to find degradation and be able to work out the other areas that you haven't inspected. But when you actually start splitting it up, it can be very different. So they are new concepts, and at the moment there's not a lot of information out there about what to sort of expect in terms of how dense you can expect, for example, CO2 corrosion to be. It is discussed further in the guidance notes, and some examples are given, and it's quite a common sense approach. So for example, something like under deposit corrosion is likely to be low density and low spatial homogeneity, because it can just be very isolated if you just have one deposit sitting on the bottom of your vessel. Once you've determined your coverage and you could then move on to recommended techniques. You have to set what inspection techniques, and the recommended practice has now got a simplified approach to this. It's got a table that looks at vessel features and what strategy that would be applicable to, and some suitable techniques. So it just makes it a little bit easier to specify what techniques would be suitable. And the evaluation section, this is often the bit that people forget to do, but we have to check that the inspection actually met the requirements that were set out. The recommended practice now separates out the concepts of conformance and analysis. So in conformance, you're basically saying, did we get the right coverage? Did we get the right locations? And did we use the right techniques and probability? And did we achieve that probability of detection? There's some updated definitions of conformance in the recommended practice. The analysis section, so the bit where we're saying this is how you determine corrosion rates and things, now includes information from the HOIS statistical analysis recommended practice. So to summarize the changes that have been made in terms of updates, it's a HOIS publication now rather than DNVGL. We've removed the screening condition was it designed for NII. Type A strategy now explicitly allows carbon steel vessels, and the technique selection advice has been updated, and there's been updates to conformance levels and evaluation phase. In terms of new things, there's the strategy flowchart I showed you earlier. There's now a quantified definition of requirements by strategy types, so all those calculations and tables are now in there. We've introduced the concepts of homogeneity and spatial distribution of corrosion. And there's first in-service inspection guidance. So there's quite a few new sections and appendices. There's a review of the candidate inspection techniques. There's some advice on vessels that are internally clad. There's some advice for designing vessels for inspectability. There's advice on if you're doing NII as a repeat, and NII as the first in-service inspection. There's also information about the HOIS work on NII and IVI trials, and how to do some evaluation of the inspection performance achieved. So I mentioned the NII guidance notes, which was an OGTC and HOIS project. So the first part of the guidance notes provides additional advice on each section of the recommended practice. But I think one of the bits that a lot of people will probably go to is the appendices, where there are a lot of examples, worked examples, for each different inspection strategy type. For a deferral when you've got limited history. It also looks at when NII is not suitable, because NII is not always the best option. It also provides some successful NII stories, some unsuccessful NII stories, and it's got some frequently asked questions, and it's also got a 2-page summary to make it easy to put to managers the case for the use of NII. Is explained in sort of more accessible language. So in terms of some examples of applying the recommended practice, this is an example of where there was a hydrogen sulfide absorber. Internal visual inspection was required, but this was going to involve the removal and replacement in the correct order of 30 trays. So they'd also have to get the correct orientation of the trays, which would mean internal scaffolding. Some surfaces were obscured from visual inspection anyway, and it was going to involve a 5-week outage. The client did an NII campaign on it, which was involved a type A and a type B inspection. So the vessel was divided up into 2 regions, and different inspection strategies applied. It was a 3-week inspection, and the vessel was in service the entire time. And even the inspection on its own cost 50% less than doing internal visual inspection. So this was quite a success for that operator. So what next? Well, interest in NII continues to grow. particularly as budgets are hit even more. Advanced inspection techniques are becoming much more standard. So what was previously you had to get in a specialist inspection company, a lot more incumbents now actually have the tools offshore. The HOIS Recommended Practice for NII on clad vessels has been published. So that's an actual bit of it's an actual recommended practice for doing NII specifically on clad vessels. We're also working on remote internal inspection, a recommended practice for that, because one of the things about that NII doesn't tell you about is things like internal furniture. HOIS is also developing a digital twin guidance document as 3D imaging starts to become a lot more popular, and being able to visualize your inspection results on 3D vessels. And obviously inspections are delivering more and more amounts of quantitative data. So there's also growing recognition of value of data and the benefits of statistical analysis in support of NII. That's me finished. So thank you very much for listening, and I will hand back over and I can answer questions at the end after Neil's talk.
Thank you very much, Susan. Please raise your hand if you can hear me. Actually, I can't.
Yeah.
Oh, perfect. That's great. As mentioned before quite a few times, actually, we are receiving quite a good number of questions. Please feel free to post your question in the chat box, and our vice chair will take it from there and hopefully ask the questions at the end of the presentation. For second part of today's event is our second speaker for tonight is Dr. Neil Wilson, who is Principal Corrosion Engineer at ENGTEQ. Neil has over 8 years of experience in materials and corrosion engineering in the oil and gas industry. In total, he has more than 18 years of experience in the process industry, having previously worked in chemical and pharmaceutical manufacturing development for 10 years. Neil's experience mainly covers asset integrity management, but more recently he has been involved or developing ENGTEQ and CAN's non-intrusive inspection experience and capabilities. He holds an MSc in Corrosion Control Engineering from the University of Manchester and a PhD in Chemistry from the University of St. Andrews. Please put your virtual hand together and please welcome Neil. You can take over, Neil. Can you please share your screen, Neil?
Yeah, I'm trying to do that just now. Just a moment. Share.
It's good to go, sir.
Can you see it? Just a moment. Right. Thank you for your kind introduction, Ijaz. And good evening to everyone. So before I, right, it doesn't matter. Before I start, I should say a little bit about the company that I work for. So ENGTEQ is a part of CAN Group, and we provide a range of integrity management, engineering and consultancy services to the energy industry worldwide. So ENGTEQ have got experience in providing a complete non-intrusive inspection package, and in conjunction with CAN's advanced NDT capability, we can provide the full service, which is fully compliant with HOIS RP 103 wherever possible. Change slide. Yeah, here we go. So today I want to give you a brief overview of the recommended practice. I'm trying not to overlap too much with Susan from her presentation, but there'll be a little bit of overlap, obviously. So I want to emphasize as well how NII fits in with the overall RBI process. Have a look at the individual steps in the NII process, which Susan's already covered: the assessment, the work scope, inspection, and then evaluation. And then I also want to discuss a little bit about the three strategy types, A, B, and C, and go into a little more detail about internally clad vessels. So non-intrusive inspection should really be a team-based activity. So in exactly the same way that risk-based inspection is a team-based activity, and really for the same reasons. So it's multidisciplinary, which requires input from corrosion, integrity, inspection engineers mainly, but it might require input from other disciplines such as chemistry, process engineers, operations, etc. And one of the main reasons for using NII for the benefit of the operator is related to the cost savings. And as Susan's already said, these cost savings aren't necessarily down to lower inspection costs, but down to less plant shutdown time required for inspection. So the equipment is normally inspected while the plant is still operating, and therefore it's still generating income at the same time. So senior management really are required to buy in to this approach and appreciate that it might not be a cost saving in the conventional sense where there's money left over in a budget, but instead you increase your annual production. So for example, if there are 52 weeks in a year, every week shutdown saved equals approximately a 2% increase in production. Corrosion engineers often play a central role in non-intrusive inspection and will be required to prepare much of the assessments and documentation, which is again similar to RBI. And in my personal experience, it's usually down to me to prepare the assessment, the work scope, and the evaluation documents with input from others, of course, although this might vary between companies. So the HOIS Recommended Practice doesn't say that this must be done by a corrosion engineer. It's just quite often that's the way things work out. So even if the corrosion engineer, if you are a working corrosion engineer and you're not directly involved with NII in the way that I am, then you might see the results for NII when updating an RBA, for example. So I want to discuss about how NII and RBI fit in together. So NII isn't really a standalone process. It is in the context of RBI and an inspection. So it doesn't aim to replicate the full RBI process. So the figure that's on the slide is an example of a full RBI process or cycle, in this case taken from API 580. So in this case, the non-intrusive inspection really fits into the inspection plan box. So that's only one box in that whole cycle. And all the other parts of the process are driven by the RBI. So for example, the consequence of failure or the risk ranking aren't really looked at for NII, and nor should they be really, because this would just be duplicating what's already been done in the RBI. So NII is heavily reliant on the information available already in the data and information collection state box, for example, and all this information should be readily available in the integrity management system already. And the more readily available this information is at the correct level of detail, it makes it much easier to make a case for NII. Most of the inputs for the NII are the same as are required for an RBI process already, so this should really be a straightforward exercise without requiring much additional information. But rather than just taking what information is there already, the information should be critically reviewed for the NII to ensure that it meets the required level of detail and accuracy. So, for example, do the damage mechanisms in the RBI and the corrosion rates, for example, do they make sense for the vessel in question? And of course, at the end of the NII process, the outputs of that, so that's the evaluation report and the inspection report, should then be fed back into the RBI cycle. So just to reiterate, NII is not a substitute for RBI. You can't determine the inspection interval from the HOIS Recommended Practice, and that's one of the key outputs from the RBI, so there's no point in duplicating it. One thing to say about that is that it is possible to assign a fraction of the existing interval as an inspection to justify an inspection, which is perhaps a deferral scope, for example. So if you wish to defer for a specific fraction of the existing interval. So moving on to the first inspection type, which is, as Susan's already introduced, a type A. So this is where no degradation is expected and usually applies to corrosion resistant alloy vessels, most commonly stainless steels, but maybe other materials as well. The most recent update to the recommended practice also allows carbon steel vessels with very low internal degradation rates to be inspected as a type A strategy. So that is, for example, vessels in dry gas service with sufficient inspection history and high confidence that there's no process upsets and things that would cause internal corrosion. And so, as you might imagine, type A inspection also applies to carbon steel vessels which are internally clad with a layer of corrosion resistant alloy. And one thing to point out about this, this is only mentioned really in the HOIS G0226 guidance on NII of clad vessels, is that there's now a new type of terminology here, type A+. So this type A+ terminology isn't used in the recommended practice HOIS RP 103 for NII. But I want to talk more in a few slides later on about clad vessels. So this is a typical example of a standard type A inspection, and this is taken from the HOIS guidance notes. So typically you would be inspecting 5 to 10% of the surface area. The areas selected are spread throughout the vessel. So remember that no degradation is expected in this case. So we're looking to confirm the absence of degradation in all locations throughout the vessel. One thing to point out is that there's a higher coverage at the nozzles. So there is a much higher number of nozzles selected than the 5 to 10% for the shell. And in this case, the reason for this is that the main process nozzles are considered to be unique. They may see different process conditions to the rest of the vessel shell, so they should be considered individually very carefully. So some of the minor nozzles might be considered, can be grouped together and be considered similar. So on the right hand side at the bottom, you might see nozzles N6A and N6B are clearly similar, and only one of those has been selected for inspection. There's no real value in inspecting both of those in this case. So this is really what you might expect to see in the inspection results for a type A inspection. And in this case, this is a hot roll bond cladded vessel. So this is a carbon steel vessel that's internally lined with corrosion resistant alloy. And the hot roll bond cladding are the most common types, where the stainless steel and the carbon steel are fused together by rolling at temperature in the mill, and then the clad plate produced is then used to fabricate the vessels. So this results in a plate with a fine grain structure in both the substrate and the cladding. So this means that angle beam shear waves are often possible to be used for detection of stress corrosion cracking in the vessel shell or the cladding layer. So inspection techniques should be sensitive to low-level degradation in the corrosion-resistant alloy clad layer. And so typically we would be doing a 0 degree method for wall thickness along with an angle beam UT method for signs of cracking. Extensive in-service stress corrosion cracking is likely to be detected in most cases. However, detection of localized finer scale stress corrosion cracking is more difficult to conclusively identify, and there's a risk of false calls due to backscatter from the clad layer. So there's currently no method with the capability to detect fine hairline pitting on the internal surface of the cladding either. So in the diagram on your screens just now, so this is an example of a 0 degree method for wall thickness only. So we're not looking for cracking in this inspection. You might be able to see between the outer wall and the back wall, there's a faint blue line, which is the location of the interface between the cladding and the carbon steel substrate. So you can see that there's been no breach of the clad layer in this case, and there's no areas of disbondment or wall loss, and therefore we can be confident that the cladding is still doing its job. Moving on to a type A plus inspection. So this image is taken again from the HOIS guidance notes on the NII of clad vessels. So you can see in the outer areas are hot rolled clad. So these are nice smooth areas with a nice uniform surface. But at the area of the nozzle protrusion and inside the nozzle bore, these have been clad with weld overlay cladding. So this results in a much coarser surface with an uneven surface, where the unevenness is determined by the width of each weld bead. You also end up with a coarse grain structure, which can cause difficulty in inspection. So the coarse grain structure can limit the effectiveness of angle beam ultrasonic methods and their ability to detect stress corrosion cracking in the cladding. So the coarse grain structure tends to scatter and attenuate ultrasonic energy. Therefore, the detection and sizing of cracking at the cladding inner surface is challenging on weld overlay cladding. In addition, the uneven internal surface due to the individual weld beads can cause increased reflections when using angle beam methods. The use of angle beam compression wave DMA probes gives lower levels of backscatter than angle beam shear waves, but stress corrosion cracking detection is still likely to be unreliable. Is unlikely to be reliable, rather. So given the very low amplitude of signals obtained from the more localized forms of stress corrosion cracking. So the higher level of signals from a more extensive form of stress corrosion cracking would be more likely to be detectable, but there's currently no published evidence available to support this. So we have to come to the conclusion that it may not be possible to detect fine pitting or stress corrosion cracking in weld overlay cladding. But then these are the morphologies of concern most often in stainless steels. So how can we inspect weld overlay clad vessels if there's no reliable way to detect fine pitting or stress corrosion cracking? So we have to look at the the interface and the carbon steel substrate itself for signs of damage. And this is what we mean by a type A plus inspection. So where there's a reasonable likelihood of failure of cladding, the inspection should aim to identify any delaminations between the corrosion-resistant alloy cladding and the vessel shell. These can occur immediately after manufacturing, but they can also be caused by surface-induced degradation. And in the case of stress corrosion cracks developing in the cladding, you'd expect them to grow and reach the interface, and it's most likely that they would then cause delamination or disbonding at the interface, since the mechanism for continuation of crack growth in carbon steel would be different to that for the clad material. So if the conditions are right, there is a possibility of cracks from the cladding progressing through the interface into the carbon steel, or under cyclic loading conditions by fatigue, but this is probably less likely. So if corrosive fluids reach the interface due to cracking or any other local failure of cladding, then this would lead to corrosion of the carbon steel starting at the interface. So this is the most likely scenario, and this is the current focus for NII carried out in clad vessels. The scenario would potentially lead to high corrosion rates in the carbon steel base material, following failure of the corrosion-resistant alloy cladding. So the purpose of a type A plus inspection is still to confirm the absence of degradation, but due to the difficulties associated with detecting low-level degradation, a significantly higher coverage is required. So again, in this inspection image here, it's very similar to the previous image I showed you, but you can see that there's no delaminations, there's no corrosion, there's nothing happening at the interface. So again, we can say that the cladding is doing its job. So the second main type of inspection strategy is a type B. This applies when the degradation rate is low to medium rate and is predictable in the degradation likelihood, the location, and in the rate. And again, this information should be available from the RBI. And all these inspection types are very heavily dependent on the information that's already available. Coverage in a type B inspection is typically higher than a type A. It's usually 25% as a starting point, although it may vary significantly from vessel to vessel. It may be less, it may be more. And coverage is determined using the equations that have been added to the current version of HOIS RP 103. So this is a sampling inspection, so that in the areas that haven't been inspected, it's important to estimate the worst case flaw in the areas which haven't been inspected using statistical analysis. So this is a typical example of a type B inspection, again taken from the guidance notes for the recommended practice. And coverage in this case is focused on the areas where degradation is expected or predicted to happen. In this case, you can see that this will be the bottom of the vessel, so you might expect to see a liquid layer here, and possibly also solids collecting. And then the rest of the vessel is subject to a sampling inspection with coverage spread throughout the vessel. So the results for this inspection may then be used to estimate the worst case flaw for the remaining area by statistical analysis, provided that the areas inspected are representative of the areas that haven't been inspected. So note again that the nozzle coverage is similar to the type A example. So there's more than 25% coverage at the nozzles. So again, you're looking at the main process nozzles individually. So that's the inlets and outlets, for example, and then a sample of the minor nozzles. The third and final inspection strategy type is a type C. So this is applicable when degradation is expected to be medium to high rate, but the location can't be predicted. And the aim of a Type C inspection is to directly measure the worst area of degradation. So this is typically applicable to carbon steel vessels with an internal organic polymer-based coating. So the coating there protects the carbon steel, but unfortunately, organic coatings have a finite in-service lifetime, and this can be very hard to predict. So some coatings can fail very quickly, within a year or two, and others could last for decades. But once the coating fails, the carbon steel is exposed and may corrode quickly. So the location of coating breakdown is considered to be random and is therefore impossible to predict. If it's not possible to inspect for coating condition, so we must inspect for wall loss in the carbon steel. It is also not possible to estimate what's happening in one location based on another, unlike in a Type B inspection. So if, for example, we were to inspect 50% and find no corrosion, there's absolutely no confidence that there's no corrosion in the remaining 50%. So we must inspect as close as possible as 100% of the vessel. But this could be time-consuming and expensive and is a potential disadvantage, especially in the case of large vessels. Oops. So non-intrusive inspection is really for the detection of internal corrosion only. External corrosion isn't addressed. But this is obviously the case for an intrusive inspection as well, of course. So the requirements for an external inspection should be set in the RBI. This includes the inspection frequency, which might be different to the internal interval. But one thing that needs to be considered is it possible to overlook external issues? So quite often we inspect vessels with more external corrosion than internal corrosion. So take, for example, corrosion under insulation. So corrosion under insulation, as I'm sure everyone knows, is one of the main corrosion threats in the oil and gas industry. It's very difficult to predict the location and the severity of CUI. And there's no universally adopted inspection strategy. Usually strategies revolve around removing insulation and examining the substrate underneath. This might be a full removal or a partial removal, or using NDT screening techniques in conjunction with some insulation removal. But if you consider a hypothetical scenario, and the two pictures I've got on the screen here are from two completely different vessels, so it's a completely hypothetical scenario that if you were to do a Type B sampling inspection where the insulation removal was driven by internal inspection, but you don't assess the external condition in the areas that aren't removed. So have you removed sufficient insulation to assess the external condition, and does the inspection meet the requirements for a CUI inspection? Now, different people have got different requirements for CUI inspections, so it can be quite difficult. But the insulation removal should be driven, in this case, also by a CUI inspection, rather than just relying on the areas that have been removed for internal inspection. The final stage in the NII process is the NII evaluation. So once the inspection is complete, then this doesn't mean to say that the entire NII is complete. So the conformance and the analysis of the inspection results are very important, and it's this output which should be used to feed back into the RBI cycle. The analysis and evaluation of the data collected in the inspection is much more involved than it would be in a more straightforward example of pipe work. So in the case of pipework, the aim of inspection is just to quantify wall thickness, and the inspection report is usually the final output of the inspection. In the case of NII, the task is only fully complete once the evaluation report has been issued. The inspection results should be compared to the requested work scope and look for any non-conformances in the inspection techniques, the surface area coverage, and the locations inspected versus what's been requested. And what has actually been found in the NII, what do the results mean versus what's been predicted to be happening inside this vessel? Are the predicted locations correct? Are there any new previously identified damage mechanisms? And on the other hand, are there identified damage mechanisms which don't seem to be active? Most of the advanced NDT inspection results are quantitative, and they allow us to calculate accurate corrosion rates and estimates of remaining life. It also increases the confidence in the ability to predict types and locations of damage for future inspections, and provide us with information about spatial distribution, that's the density and homogeneity of corrosion that Susan was talking about earlier on. And these things are not typically possible using traditional intrusive inspection techniques. Therefore, this is a major advantage of using non-intrusive inspection. And all the information that's gathered in the NII should then be fed back into the RBI cycle. So my last slide is just a brief summary of what I've said already. I want to emphasize really the importance of how NII fits in with the RBI, that the RBI influences the NII, and then the NII feeds back into the RBI again in the traditional cycle. And it's important to think about what the findings are against what's been, what was expected. And this should all be updated in the RBI, so the damage mechanisms and the likelihood of failure, and then leading into the overall risk, etc. So that's really all I want to say. Thank you for your attention.
Thank you very much, Dr. Neil. And with that, I would request Human to streamline the questions. If you have them ready, fire away, Human.
Yes. Good evening, everyone. We have quite a few number of questions, which is very good. And that was expected because of the hot topic that we are discussing today. So I will go through the questions, and the chat box is still open. If you have more questions, please feel free to add to the chat box. We'll go through them. We still have time. The first question is actually, there are a couple of questions related to the cladding, which I think Dr. Neil has gone through that in detail, asking about how, please advise what has been included for clad vessel NII in the new guidance, which has been already discussed. But for Dr. Susan, if you have anything to add related to this, because it has been asked a few times.
No, I think Neil covered it. I mean, yeah, you can use NII for a clad vessel. Obviously, much easier on roll bonded than weld clad, but it is just a case of increasing your coverage and thinking more about the risks involved in case you do miss degradation. Yeah.
Okay. A question from Dr. Ijaz. Thanks, Dr. Susan, for a very good presentation. If full NII is not possible due to access, is it possible to defer internal visual inspection through partial NII?
Yeah, Neil mentioned that actually in his talk, that the recommended practice does have a set of calculations that you can use. So that if you haven't managed to achieve the coverage you were aiming for, you can calculate a percentage of the interval that you can use. So you think of it as deferral. So yeah, you can, if you can't get access to 100% and you need 100%, you can go in with a shorter inspection interval instead.
Okay, thank you very much. There is a question actually from an anonymous participant. His attention to Dr. Susan again. He or she is thanking for your excellent presentation. And the question is, for this more comprehensive third edition, are HOIS currently initiating training courses to ensure that there is high levels of competence in NII implementation within the industry?
HOIS are not running training courses, although ESR Technology, who run HOIS, can offer training courses if people were interested in it.
Okay. The next question is from HS Srinivasan. Can NII be used for internally coated pressure vessels?
Yep. So again, Neil mentioned that in his talk, that for something that had like an organic coating on the inside, it would have to be a type C, because we can't determine where the failure in the lining might happen, but it is possible to do NI. It's just obviously a much bigger inspection task.
Yeah, thank you very much. The next question is from Scott Niblock. How does the update to the recommended practice impact operators that have existing NII assessments in place? Are the existing NII assessments in place acceptable? Upon completion of the next NII, do the existing NII assessment need to be revised in accordance with the new RP?
So what I would say is that it's the update to the recommended practice hasn't made previous NIIs invalid. It's more just that the updates were supposed to make it easier to apply NII. So a lot of people will probably have been doing a lot of the things that are in the recommended practice anyway. For a type B, you were probably putting in 20 to 30% coverage or something like that. So I guess it's a case of you might want to pick a couple of vessels and see if there's any difference. But for most of it, I think it should be fine. But in terms of when you do your next NII, yes, I would recommend looking at the new recommended practice, because doing a repeat non-intrusive inspection, there is now advice for going on and doing another one, because you don't want to just keep going back to the same areas. If you're doing a sampling inspection, you do want to increase your coverage or change some of the areas that you're inspecting. Yeah.
Okay, thank you very much. There are a couple of questions related to the pipelines. Maybe asking Dr. Neil about that. The question is from, again, Srinivasan. Can NII be deployed for pipelines to detect localized corrosion? And another relevant question from Ogor Novokolo, sorry if I'm not pronouncing your name correctly. Could NII be used, or could this guideline be used for ICDA for pipelines?
You're on mute, Neil, I think.
Sorry, thank you.
Yeah.
So the general principles of the recommended practice are usually applied for pressure vessels, but they're also applicable to other things as well. So they can be used for pipelines. So yes, in principle, yeah. Depending on your inspection, what inspection is actually physically capable. But if you can meet the general the general requirements of the recommended practice, then it should be applicable.
Yep. Okay, thank you very much. The next one is not actually a question, it's kind of more information. From Dave Jones, proceed with caution, promising cost saving from NII. Inspection cost is 3 times installation and scaffold cost, and you still run the possibility of not detecting a defect. Field owners keen to defer shutdowns, but sometimes less keen to support the NII implementation and POB for detailed inspection. Any comment on this?
Yeah, I mean, the cost saving isn't the only reason for doing a non-intrusive inspection, and that's something that everyone should be really aware of. And if there's no real cost benefit and there's no other benefit from doing NII, then it may not be an appropriate strategy to take. It maybe be better doing an intrusive visual. And I mean, that's true for every vessel, that they should all be assessed individually, and cost is one of the factors that you should be looking at, in addition to safety and the general pains associated with breaking containment. But yeah, every vessel should be assessed individually to see what's the most suitable strategy, an internal visual or a non-intrusive.
Okay, thank you very much. The next question is for Dr. Susan from Bruce Mackenzie. Where we have, say, a solid duplex vessel in hydrocarbon service, and we don't have any predicted degradation and no IVI, what's your thought on NII for first in-service inspection after a few years in service? High coverage versus low coverage? Also, similar question for carbon steel vessel with CRA cladding.
Yeah, so with not much information, so I would say that you could consider first in service inspection for something like a solid duplex vessel, but it would really depend on what information you have. If you have very good fabrication records, quality assurance records from the fabrication, if you have good a baseline inspection from before it went into service, and things like has there been strong process monitoring, things like that. But you would be expecting to do a much higher coverage than if it was an NII after an internal visual. And going back to people's the question or the comment there about the cost, that's something you would have to weigh up. Is it better to just pay for an IVI up front, because the next NII will be a much lower coverage? So it's definitely possible on a duplex one for first in service. The carbon steel with the cladding is a bit more of a concern. I mean, again, you have to look at it on a case-by-case basis and see how much information you've got. But cladding, depending on the type of cladding, there's certainly more that can go wrong in the manufacture of it, and that would be one of your concerns. One of your big concerns is that there's a manufacturing problem that has been missed, and that's coupled with the corrosion problem, and that would be a big risk doing first in-service inspection. So again, I'm not saying no to it, but you would really have to look at all the information you've got for that vessel.
Yeah, great. Thank you very much. There is a question by David Corbett. Does the HSE accept or approve this publication for the use of NII for the first in-service inspection of hydrocarbon vessels? We have been challenged with our original NII recommendation for first in-service inspection. Just to note that these vessels are all built with corrosion-resistant materials, 2020 chrome, duplex stainless steel. Have you any experience in this issue? As you said, the cost to carry out internal mandatory inspection is a lot higher than NII, which is kind of answered just now, but if you have any additional note on that.
Yeah, I mean, in terms of the HSE's stance on it, they didn't ask us to remove it from the recommended practice. I mean, obviously the recommended practice is for more than just UK use. So like I said, in Australia, they have this requirement to inspect the vessel within the first year, which is much more stringent than we have in the UK. So for them, doing NII as a first in-service inspection can help a lot. I haven't had the HSE specifically say to me that, you know, they wouldn't, you know, that this first in-service inspection isn't suitable. I think it is a case of, again, it's arguing on a case-by-case basis. And it's difficult to know if, depending on what inspection scope you have done for these vessels. Yeah, as I say, the HSE, they never like to say a definite no, but they are cautious about first in-service inspection with NII.
Okay, thank you. A question for Dr. Neil. Thank you for an informative presentation. If corrosion has passed through CRA lining and NII finds crack and pitting, how much time one would have to for failure in carbon steel based material?
Again, it's hard to say on an individual case. But obviously, the corrosion resistant alloy is there for a reason. It's there to protect the carbon steel, and you wouldn't expect if your material selection has been done properly in the beginning, you wouldn't expect your corrosion resistant alloy layer to degrade. But in the event if it did breach the carbon steel, then obviously carbon steel isn't a suitable material for the process fluids in that vessel, and you would expect quite high corrosion rates. So depending on the wall thickness and everything, that failure might happen really very quickly. I couldn't really put a time frame on it, but probably less than your next inspection interval. So in that case, that's not a very good scenario to be in.
Yeah. Okay. Thank you very much. The next question is again for you, Dr. Neil. What is the confidence level of NII to detect environmental stress corrosion cracking damage mechanisms, for example, for HIC or SSC?
There are suitable inspection techniques for determining cracking mechanisms generally. So the confidence level should be, should be fairly high, I think. And this should obviously be assessed for looking at the work scope and the assessment of any individual vessel. So you would do your coverage and choose the correct inspection techniques if these are the damage morphologies that you're actually interested in. Mm-hmm. But there's, broadly speaking, they should be possible to be detected. Yeah.
Yeah. And the other one is related to the organic coating by Kenneth McKee. The question is that coating failure may have some degree of predictability, for instance, at the edges or areas of abrasion. Can these be taken into account?
I think the short answer to that is no. So yeah, I mean, the areas there are areas that are more susceptible to failure, you would expect. So edges, for example, and welds and things are quite often predicted to have a higher likelihood of failure. But quite often you see just random areas throughout the shell. So you really need to do a full coverage as close as possible to 100% in order to be sure that you are identifying the worst area of degradation.
Mm-hmm. Yeah, thank you. The last question in the chat box is actually addressing both the speakers by Bruce Mackenzie. Is there any specific software for RP103 that you utilize?
For me, no. I don't know if Susan has anything.
Yeah, well, ESR Technology and Quasit have just, we were developing a digital support tool for the recommended practice. So it's based on digital twins. Obviously, a lot of people might have their own internal tools and things, but so yeah, at the moment, that's one option.
Okay, thank you very much. That was all the questions that we have for tonight. And before I pass this back to Ijaz, thanking you both for very, very good and informative presentation and for your time tonight.
Cheers. Thank you very much. Actually, I would like to thank the audience as well. Actually, we received quite good number of questions, and apparently quite good questions there. So I would thank the audience for participation as well. With that, I will probably like to mention that if you have been you have attended the presentation today, more than half at least, then you would have been noted as the attendee, and you would be requested to fill in the survey. And if you fill in the survey, you would there is an option that if you require any CPD, please mention there that if you need a CPD certificate, and that would be issued to you hopefully in due course. The other thing is that the next event we have is next month, that is on 24th of November, and that's in collaboration with Mining Institute, which is a part of Institute of Materials, Mining and Minerals. So we will be having an event on body armor, why, how, and what from. Proactive presentation to get you thinking out of the box. It is actually more of a materials corrosion, bit of, it's not much of corrosion there, but it's quite interesting to think about composite material coming into the arena, and that could be used in certain areas. So it will be presented by Professor Deborah Carr, Defence and Security Accelerator team. She is DASA Scotland Innovation Partner. So we would like to invite you to that presentation. Please join us for next presentation in November, hopefully. And with that, I would like to thank Dr. Susan and Dr. Neil on everybody's behalf, on Institute of Corrosion Aberdeen and Institute of Corrosion headquarter, as well as all the audience here. And I would like to thank everyone for joining us this evening. And with that, I'll say keep safe and enjoy rest of the evening. Thank you very much.
Thank you.
Thank you.